Hi, can everyone hear me all right? I'm guessing, so, okay, cool. I'm Chris Sumner, joined here today by Randall Wald, who's going to be focusing on some data science, machine learning. Probably kill me for saying data science. And our talk is on predicting susceptibility to social bots on the Twitter platform. So a quick intro into how I got into all of this. Maybe about 10 years ago, a friend of mine back in the UK said, "Hey Chris, you can make money on horse racing because now you can bet against horses." And here's me thinking, well, okay, betting against horses, that's got to be pretty easy, right? You know, so you just pick the one that looks least likely to win, bet against it, and watch the money roll in. So, but it turns out it's not quite that simple, actually. But that's how I got into sort of looking at data analytics and machine learning to see how can I reduce the odds of the bank blowing up in horse racing. And then in terms of social media a few years ago, I got involved in a little project with the US skateboarder Tony Hawk hiding skateboards around the place, and I wanted to see how that would map out and who spoke to who on Twitter regarding that competition. So a sort of an interest in could I improve the odds in horse racing and the social network side kind of came together, and from that formed a small charity called the Online Privacy Foundation, where we focus really on what's called behavioral residue research, which is looking at what people give away without knowing it in terms of their personality. So with that said, and this being Vegas and all, one thing I wanted to be sure of in this presentation, if you're expecting sort of laser accuracy in terms of predicting people who are going to respond to a social bot, that's not going to be the case. We're really just focusing on improving the odds over a random chance. So if you're expecting laser accuracy, you may be a trifle disappointed. So anyway, with that said, I just wanted to sort of lay the limitations down. Is anybody familiar with this guy? Tim Hwang, yeah, and Tim Hwang, this is how I got interested in social bots, really. Found out that he ran a competition back in 2011 called the Socialbots competition. Essentially what that consisted of was they set up a target group of people on Twitter who had some interest in talking about cats, cat-related kitten stuff. And he set those up as targets and invited people to build social bots and come and join the competition. And there were 3 teams that competed in that competition, and their bots were able to gain points, and they were able to gain points like +1 if they got a follow back, 3 if they were able to get some social interaction, and they were docked 15 points, but they could respawn if they were killed by Twitter, and that's basically suspended by Twitter. And it was described as blood sport for internet social science and network analysis nerds. And if you're not familiar with it, there's a couple of really neat videos online. I put them in the speaker notes so you can go and find them, all about the competition. But that was interesting. And the winning bot was able to get almost 40% social response, or some form of response, 198 out of 500 responses, by a chap called @Aerofade on Twitter, at least, a guy from New Zealand. So with that, most of the research to date is really focused on how do you detect spam bots in social networks, or spam bots in general, but far less research in looking at human behavior in relation to, so the other side of the equation, human behavior in relation to social bots. So last year, when we did some research looking at psychopathy and other personality traits, I might add, on Twitter, at the same time, that was kind of when we were thinking about the social bots thing. We thought actually it'd be neat if we could encourage some folks to participate in a further research project where they'd receive an unsolicited tweet, but not necessarily know when that tweet would be or who it would be from. So we were able to get out of the 3,000 odd people that took part in the sort of psychopathy dark triad research, a subset of those users took part, volunteered in this, because we had 2 questions. One being some users more naturally predisposed to interacting with strangers online. I used strangers because you could argue that a social bot's the same as like interacting with a stranger online. And also, is it possible to increase the odds of getting a response from a Twitter user? With the main goal of avoiding Twitter jail, essentially. So a reasonable question at this point is really who cares? If you're not familiar with this dude, it was Different Strokes. It's like meant a lot to me in my childhood. Well, in terms of who cares, marketeers possibly care. The game used to be for marketeers to really get like likes and follows and stuff like that, but it's shifting now to more engagement. So they're being gold more on engagement rather than just getting likes and follow count. So they may be interested in gaming the system because there's money at stake, and where there's money, you get the idea. The next group that might be interested in exploiting this would be propagandists who have got some message to try and get out or change subtly some form of message. And we'll talk more about these in detail as well. The next group would be social engineers who are maybe trying to find the most likely person or most likely sort of phishing victim in an organization and try and target them rather than the people who are less likely to respond in the first place. Again, I'll talk a little bit more about that in the slides to come. In terms of online privacy, this was kind of where I was scratching my head for a little while earlier in the year. There's a chap called Erhard Graf out of MIT. He's got a really neat paper, if you've not seen it, called What Should We Do Before the Social Bots Take Over? Online Privacy Protection and the Political Economy of Our Near Future. And one of the things he mentions in that paper is that if humans are interacting with social bots and they don't know they're social bots, they may give away more information than they would if they knew it was like an automated account. So it may encourage them to do riskier behavior, maybe share personal details over direct messages in Twitter, for example, or IM or whatever it's called in Facebook. So it's a neat paper. If you've not seen it, it's well worth having a read. And the final group that have got some interest in this whole field, social network providers themselves. I can't recall exactly what the paper was where the cartoon was from, but it's a pretty funny one with lots of robot cartoons. But so Facebook, for example, have got Facebook Immune System, and it's this sort of constant revolving battle of them improving their algorithms to detect bot and bot-like behavior, and then the bot creators getting an advantage and so on and so forth. They're actually pretty good. And Twitter have been doing, I guess, something similar, because you can see the way that they've tackled spam bots really was pretty effective, at least a few years ago. So we set to work in building some bots to actually analyze this for ourselves. So in terms of the rest of the talk, how it will go down essentially is we'll look at the history and sort of current research of social bots. So if you're intimately familiar with Tim Hwang, this next 10 minutes may be a little bit light for you. Then we'll talk about the experiment and the method, talk about the findings, and wrap up with some conclusions. So for social bots, there's an interesting working definition by a group of researchers from Austria called Wagner and company. A social bot is a piece of software that controls a user account in an online social network and passes itself off as a human. So we could debate that, but it's good enough. You can also hear social bots maybe described as Sybils. It's not quite the case, but it's probably good enough. And that was a phrase coined in 2002 by John Doucer at Microsoft Research. That's also pretty interesting paper that he wrote there. Then you can argue that social bots aren't nothing new, and you'd be right in doing that. There's at least a paper in '94 that talked about chat bots on Tiny Muds and what have you, and there's probably stuff before then. So, okay, let's take a look at some of the sort of the historical developments. You've got popularity initially. This is where people were getting lots of fake followers, and that was what people were going for. I mentioned rather than engagement, people were going for likes. So that was an obvious, rather trivial one. The next one, which kind of see a little bit less of these days, is just the Twitter spam that you'd get. If you mention anything, all of a sudden, they'd be talking about, diet products, which I haven't tried myself, evidently. Some Twitter bots are actually pretty amusing. So this was a guy who says, I don't know how you can read this, if this is sufficiently clear from the back of the room, but had a successful auction yesterday, thank you, universe. To which the universe replied, no problem, Kevin, get out there and do your thing. And there's a bunch of these sort of bots out there. There's one that I'm particularly sad to have seen gone, which was, I think excuse the French, but the world of shit bot was, so every time you mentioned Full Metal Jacket, it would give you grief over Twitter. And I'm kind of sad that doesn't do that anymore. But there's another guy here, Nigel Leck, I think in Australia, it might be New Zealand. He got tired of debating climate change deniers, so he built a bot that would go and point climate change deniers to research that showed the other side of that argument. Unfortunately, that's been shut down as well, but that was a pretty amusing, piece of work he'd done there. In terms of exploring social bots on Twitter, this was arguably one of the first pieces of work there by a guy called Greg Mara, who created this Real Boy project, which had a bunch of bots that used different ways of actually approaching how you create a social bot, maybe taking posts from other users and then reposting them somewhere else in another part of the social graph. That's pretty interesting stuff to look at. So it brings me to politics, and I don't know if anybody was in the Maltego talk that just preceded this, but Roelof Tamingi, I've failed at the name. I practiced that with Roelof just like an hour ago. But Roelof and Kenneth Gears, they wrote a paper in 2009 called Virtual Plots and Real Revolutions, where one of the things they stated here was, for example, in the week before an election, what if both left and right-wing blogs were seeded with false but credible information about one of the candidates? Could tip the balance in a close race. And then a year later, there was a US election between Martha Coakley and Scott Brown, where a bunch of Twitter bots sprung up to discredit Martha Coakley. It's a kind of a groundswell, if you like. And that resulted, or at least the result was that Scott Brown won. Whether there's a link between that actually happening is probably debatable, but that actually happened. And there's a term for that as well. It's called swift boating. I took the idea of the Taylor Swift thing from a rather excellent Twitter presentation I saw at OWASP. So if there's anyone from Twitter, thanks for the idea. There's another side to that as well, is paying people to, or creating bots. And in this case, it was the Russian elections, where people were paid to create positive information about Putin, essentially. So you could use social bots in the context of actually drumming up support for political candidates. And that's got a term as well called astroturfing, and the whole point or the reason for that name is that astroturfing is a groundroots campaign, and it feels like a grassroots campaign. In terms of identifying whether grassroots campaigns are fake or real, a project sprung up from Indiana University called the Truthy Project, where they look at not just grassroots campaigns, but also internet memes and things that are going viral, and look at where they start and see to some degree whether they've been created by fake accounts or real accounts. Then back in, I can't remember, was it 2011, the HB Gary incident, where the emails were exposed. They exposed some emails talking about the United States military looking at fake personas termed sock puppets, and controlling those. And those could be used, for example, in, there was some mention in the press about those being used in like the Arab Spring, for example. Which is interesting because that's one of the things that Roelof and Kenneth Gears in their 2009 paper had suggested, that a large virtual population scattered all over the world and encompassing different socio-economic backgrounds could be programmed to support any personal, social, business, political, military, or terrorist agenda. So their paper, although it was in 2009, we were seeing bits of that sort of come out in reality. One of the final things I wanted to mention was something that caught my attention around sort of Christmas time, was that you've got this service provider in the UK, a telecom service provider called EE, and they were coming out with tweets like this to their users who were complaining with, I don't know, service disruption or whatever. Please follow and DM your mobile number, postcode, and password. So obviously DMing passwords is fine because, it's, who sees DMs? But the interesting thing was this was picked up by a guy called Troy Hunt, who has got an excellent blog post on the topic. And he was just talking about the DM password issue. But what we noticed then was that this other account came up, My EE Care, and they came up with a sort of innocuous tweet about, can you link us to your post once it's done? But if you followed their tweets afterwards, then they got, there was some interaction saying it's good to see EE doing something positive about that. And they were like, no, we don't really care. But it wasn't EE that was sending that message, it was the My EE Care who were a fake account. So it raises the possibility that if you get in there quick, if somebody's not got a social presence, an organization hasn't got a social presence, and you can get in there quicker, then you could use social bots to interact with those humans and get them to send you information that they would probably send their service provider because they're used to this sort of stuff from a legitimate service provider, but send it to a fake account. So back to Tim Hwang, after the Socialbots competition that he did in 2011, they set up this organization called Pacific Social. And one of the reasons why they were interested in, one of the things they wanted to do at Pacific Social was really look at the social graph and how that could be distorted. So if you look on the left-hand side image, that was the social graph before the Socialbots competition, 500 interconnected users. But the distorted graph on the right-hand side is the graph 2 weeks after the competition. So they were really interested by the way that was distorted by the three bots. There were the red, blue, and green dots in the middle, because they were interested in something called like social bridge building, essentially. Whether they could get two disparate social groups on a social network and get them to begin interacting and start stitching those networks together, or also find places where there were social interactions before, look where they've dropped, and then begin mending those. Maybe you've not spoken to somebody for a while and you need to bring them together. So they were kind of interested in that. And if anybody's seen Tim's Hope 9 talk, he also talked about the concept of emotional contagion or happiness buffering. And the concept of that really was that you take a group of people and you seed that group with some bots, and you monitor that with some basic sentiment analysis. And you find that when happiness in certain members of that social group dips below a certain level, then you can start injecting happy information into that social network, or more positive tweets into that network. So what they were exploring was whether you could then actually turn some of the unhappy people into happy campers, essentially. So that's one of the things they're working on. I don't think they've concluded that, but it's kind of an interesting concept, which comes from sort of social interaction and the effect that has on many things like obesity, for example. There's a chap that's written a great book called Connected, Krista Kiss, I think is his surname, and that's not been researched that much on social networks right now, but it's certainly a topic it's pretty interesting. Tim had also mentioned social penetration testing, and what he was suggesting was that if you can spread information with small inaccuracies and then see where those inaccuracies are challenged or they're not challenged, then identify out of the group that doesn't challenge them who's the most influential but also the worst at evaluating what's real, and target them with your information and get them to tweet stuff out. So a bunch of interesting things coming out of the work of Tim Hwang and those guys. And then there's this chap here, Yazan Boschmat at University of British Columbia, who rose to some fame or infamy because he created social bots on Facebook. and was, I guess, accused in the press of stealing 250 gigabytes of data. Well, that gets back to the Erhard-Grafe paper, the MIT paper, about one of the online privacy issues of social bots. Because people were interacting with somebody they thought was a human, they were then exposing their information to a broader audience, and maybe some of that information wouldn't necessarily have been publicly available in the Facebook, graph. So one of the things that he cites in his paper in 2012 was that really understanding the factors that influence user decisions on befriending strangers is like a key goal, which would be useful for designing user-centered security controls that better communicate the risks of online threats. That was one of his discussion points in the paper. So I spoke with Yazan Boschmaff about this to some degree, and in relation to that, there are two groups that are studying understanding user behavior in terms of security. One of them is a Secure and Trustworthy Cyberspace initiative out here in the US, mainly academia and corporations working together, and another is centered in the University of Oxford in the UK, and that's called the Insider Threat Project. And both of those have identified that understanding user behavior is one of 5 critical questions to actually look at. So with that, we wanted to embark on some research that had essentially find people that will talk with anyone about anything and find some guinea pigs to do that. So that's kind of a whirlwind history, and in the slide notes there'll be a lot more material on where you can go and find like pointers to the research that I mentioned and videos and whatnot. So in terms of our methodology, we started off with 610 participants that were a subset of the folks that had participated in the research we did looking at dark triad personality traits. Those people gave us a personality inventory which looked at the big 5 personality traits of extroversion, openness, conscientiousness, agreeableness, and neuroticism, or emotional stability, depending on which school of thought you're from. The Twitter information, so sort of biography length, number of friends and followers, that kind of thing. Linguistic analysis of their tweets, of which there were roughly 3,000 for each individual, and their clout score. We divided those 610 people into 2 groups of 305 just to speed up processing a little bit, really, and assigned them each a social bot. Taking from the Web Ecology project, we wanted to mirror the Web Ecology project's bots as closely as possible, and because their code was available online, we reused their code, slightly repurposed it. So our social bot was a dear old lady who had a biography of "I've got all my own teeth," and to set this old lady's profile up, there were 2 old ladies like that. The first thing we did, and this came from the Web Ecology project again, was that they'd take postings from Flickr groups. In the Web Ecology project, it was kittens, we used dogs, and there was a bit of code that would post a WordPress post and then a WordPress to Twitter plugin, so that this person would then start tweeting bits about dog fashion and what have you. So that kind of looked like this. You'd find there's plenty of groups that will talk about dog fashion on Flickr, and that was one of the images. It then goes into a WordPress site, and then eventually it turns up into a tweet with a new blog post on a technical and dream sweater. And they could be all sorts of inane sort of posts, which you might not expect an old lady to be tweeting. The next thing we did was used an online tool called If This Then That, and in this context it said, okay, if the temperature rises above 20 degrees C in part of the UK, Bournemouth, then tweet, obviously, to the user's name, that's my Twitter handle. So she'd then tweet, wonderful, I can switch the heating off, it's 15 degrees C and sunny in Bournemouth, get in. So that would happen then every time the temperature rose above that. So it was a neat way of actually generating some content without having to do anything. Then the next thing we did is we took the target list of 305 per bot, and we followed them. You have to do some work with the way that you follow people, because the Twitter rules mandate that you don't do like aggressive following, so it takes a little while to do that following. Then if they respond, we wanted to collect that in a CSV file just with interactions, with things like when they responded and who they were and stuff like that. From there then, we'd start tweeting pretty much random nonsense, and the random nonsense was taken almost identically from the Web Ecology project, but with a few little additions that just amused us. So, for example, this was one of the tweets. For our old lady, I ain't telling no lies, even a thug lady cries. But I show no fears, I cry gangster tears. That probably works better after a beer, but that was one of the tweets, which is kind of different to what you'd expect from an old lady. So there were clues that this person might not be real. Too cute my dog is, I talk like Yoda. There was a whole bunch of tweets essentially a little bit like that. But she would only tweet those maybe 4 or 5 times a day, but there was a whole bunch that she could select from. Then, this was another example. So my dog is adorable, I swear he barks sausages. So then what we did, in the same way that the Web Ecology project did, we started asking questions of each of the users that we'd followed, as long as we hadn't been blocked. And we had a pool of 162 questions, which we duplicated so it'd go through and ask those questions, get to the end of the questions. And the questions were also fairly inane, like, ever milked a cow? And what's better, a dog or a cat? And these would actually generate some responses, which was pretty interesting. And then this was where we varied or differed from the Web Ecology project. They had just a stock bunch of responses, but we added like an ELIZA engine onto the Python script that we'd written, which would hopefully make some of the responses a bit more appropriate. So some of the responses would be like, hello, hey, how's your day going so far? Fairly legitimate. But we wanted to add some fun into that as well. So sometimes if a user would say, I think, we'd respond with interesting or lol, that's what she said. And that could be kind of at random. There were a bunch of things that they could respond with. And that mainly gave us some amusement. The other thing we had to consider, though, was the concept of ethics, because one of the things that we wanted to do in order to sort of keep in line with ethics is make sure we didn't upset anybody. And this was from the Socialbots competition, where they called this out. Do you have any pets? If so, what? Your Avi is adorable. Your kitty? No, I don't currently have any pets since my kitty passed away a few years ago. To which their bot responded, lol, that rules. So we didn't really, we needed to avoid that because that was probably crossing the boundaries of ethics. So if you mention ethics to anybody who studies social bots, they'll probably smile with a similar story. So there are a number of limitations which you're probably all thinking about. We had basic measures of personality, so fairly crude. It was a basic social bot. Each user got a different question, and as the experiment progressed, the bots would have obviously more interaction online, so maybe they became more credible or less credible, who knows. And also there was no user follow-up at the end, so we don't know whether users cared whether it was a social bot but knew or not. So these are a number of the limitations I just wanted to get out there, from the bat. So what did we find from this? Well, we got a 20% response rate, which is worse than the Web Ecology project, but there are a number of reasons why that could be. But we found that we got 124 interactions of some sort, broken down with 39 follow backs and 85 replies. And out of those replies, some people would reply and actually converse a lot more with the social bot. And some of the conversations were actually pretty funny. In terms of performance, that's kind of how it stacks up with the Aerofade bot from the Web Ecology project. You can see that ours did a lot worse, which is fine. But one of the amusing things is that the bot would often get into sort of unintended trolling. So you get a user, this is one of the questions, using no more than 10 nouns and only nouns describe yourself. Facetious, I blanked out the swear words, but it was 4 letters. Annoying. So that was kind of amusing to us. And then the bot would respond, how do you feel when you say that? Which was from the ELIZA engine, which amused me. The next thing was an interaction with a particular user. It's a cool story, bro. Shut up, I hope you get suspended. To which the bot responds, I'm laughing so hard right now. I'm not sure if the user actually saw that because they may have already blocked the bot by then, I don't know. And We also got outed as being a social bot as well. What do you do for a living? I plan, guide, and help others write stuff. You're right, and when you're right, which was a stock response from the Web Ecology Project. You're a bot, aren't you? Granny failing Turing test after one exchange. So these kind of things amuse us. So what did we find from the personality aspect? Well, looking at that, we saw that extroversion was the only personality trait out of all of the big five and the three dark triad traits that had a statistically significant relationship. So that's not necessarily that surprising, I guess, because extroverts would tend to gravitate towards social engagement and maybe not care too much because some elements of extroversion may be related to impulsivity. This is another way of describing it. So you can see that as extroversion gets really high at one end of the scale, it kind of escapes and your probability of an interaction goes to like 0.4 rather than 0.2. Clout score was also statistically significant. Friends, or the friend count, and was that friends? This one's followers. Sorry, wrong title. So what, you might well say? Well, e-learning, for example, if you work in a corporation, e-learning tends to be one size fits all. And if it's e-learning one size fits all, the people that's going to fit the best are going to be introverts because they've got least control over the learning experience. And there's some papers that are referenced in the notes about this as well. So the very people that need to be more aware of social bots and interaction with like phishing are probably the people that are going to get the least out of e-learning. So it raises some question about, do you find people in your sales organization, for example, and do some more in-depth in face-to-face sort of training? So we'll move on to talk about the data mining and machine learning. This is where we switch to can we predict who's going to respond and who isn't. Improve the odds essentially of getting a response. So this was what our baseline performance looked like. About 20% of the population responded. And what we wanted to do is obviously reduce this bit, because the more of those there are, then the more likely you are to end up with that screen. So you want to try and improve the odds in your favor essentially, and end up with something like this, where you've got all of the true positives who are going to respond and make sure you find all of the true negatives. So that would be, essentially perfection. So at this point, just want to call out precision as one of the performance evaluation criteria, really. What we deal with in precision is looking at the retrieved part of the data set. So we're not interested in the not retrieved stuff. And precision is really the fraction of retrieved instances that were correct. So in this case, it was about 20%. And that's what we wanted to improve. So at this point now, I'm going to hand over to my co-speaker here, Dr. Randall Wald from the University of Florida Atlantic University, rather.
As Chris Sumner was saying, I am Dr. Randall Wald from Florida Atlantic University. My primary focus is on data mining, machine learning, basically data science. So let me give some very basic background on what data science is. It's important for a lot of different fields, including security research and, in this case, social bots, mining and related social research. But some of you may not be as familiar with it. So this is just an example of what a data set might look like with, columns and rows, and specifically each row here is an instance which has a label, and it has a class value, and it has various feature values. So feature values are pieces of information we know about these people that we can acquire independent of the problem we're looking at. So in the case of Twitter, this is information we can find out about the person before we interact with them, before we see what they're actually going to do. So this is, for example, clout score or number of friends, where we can determine that just by looking at a profile and not having to work with that person directly. While whether or not they interact with the bot, that is the class of interest. That's what we want to learn about the person. And the goal of the data science here is to use the features, use the independent attributes in order to determine the class. This basically involves building different types of models that will use the instances we already have, use the data we collected during the training phase, and try to use that to help us understand which features can imply about the actual class values. And note also that, of course, the ID column is removed because that's not going to help you in building models. Basically, we want to build models that can use the features to predict the class. And there are different ways to try to evaluate this. Like I said, if you have training data and you want to predict test data, this is one way to look at it. For example, this is particularly if you have a large training set, then you're going to be able to take that training set, cut out most of it, use that for training, and then verify your model on the test data set. In practice, obviously, when you have a new unidentified instance, you can't tell if your model worked or not because you don't have the true value there. But to evaluate the model when doing research, you need to have the known ground truth, and therefore you have a test data set to test with. Alternately, if you have a relatively small data set, as we do here, we have 610 instances, you can't always afford to just only train your model on some of them. So what you can actually do is break your data set into K, in this case usually 10 is a good number, of folds, train on 9/10 of the data, and test on the last tenth of the data. And then you repeat this 10 times, so you get a good sense of how well your model can perform, and you're making sure that you never are looking at the performance of the model when it's trained on the same instances. This is a known issue. If you have a model and you train it on some instances, and then you say, how well does it perform on those instances, you're going to get a good performance, but that's not necessarily very meaningful because obviously the model could memorize those instances and not really do anything useful for you. So by using these techniques, we can make sure that the models are never tested on the same instances they were trained with. Now, when it comes to different models, I say models very broadly, and you probably are wondering, what do you mean? Do you mean like a decision tree? Do you mean some sort of statistical regression? And there are actually many different choices here. And the thing with data mining is no one best choice. You'd like to say, oh, this choice makes a lot of intuitive sense. Why don't we always use that? Because there are a dozen different models that you could always say, in some sense, that's the most intuitive one, that's the one you want to go with. So in order to find the best model, really the only option is to test a bunch of different options on your given data set and see what works best. Data science is not an exact science. It's basically seeing what works on real data, because real data is weird. Real data has complicated things, and you can never be certain what's going to happen until you actually experiment with it. So when you want to see how well your model worked on real data, one important thing to keep in mind is you may not have balanced data. And what that means is you may have more instances in one class than another. As Chris was saying, in this case, most people were not interacting or replying with the social bots. I believe that only 20% of individuals interacted in any fashion whatsoever, while only 13% replied. And if you just take a simple performance metric like accuracy, like what fraction of individuals that I classify correctly, that can be very misleading on such data sets. For example, you could just say, I predict no one interacted. And you're correct 80% of the time, but your model is useless. So in our research, we use different metrics such as the area under the ROC curve, abbreviated AUC, which try to give a more balanced view of false positives and false negatives to see how that our models are not just giving us a naive view and saying, oh, you got all the negative ones correct. Doesn't that count for something? You want a model that can balance both false positives and false negatives. So I noted that we had multiple features. In the little diagram I only showed 2, but in practice we have quite a few in this data set. The tool used to extract information from the tweets give us 80 different features for each tweet, for each user, telling about how they use different language terms, different words, different semantics, different punctuation. We actually divided the tweets into different categories, so we had even more. So in order to build more accurate models and more meaningful models, we wanted to figure out which features are most important. This is especially interesting in the context of this Twitter social mining, in that we don't care necessarily about all the features. We care about which features are most important for understanding how users interact with bots. Which traits of an individual are going to tell us whether they're going to interact or reply. So feature selection will go through all the features and rank them and say, these features are the most important. And these are the features that you need to use for building models. And also, these are the features you want to use if you want to understand the psychology, the mental processes that lead to individuals interacting or replying to social bots. So we employ these techniques to try to get a better sense of how these features directly relate to the class, in this case, interaction or reply with social bots. So we performed two sort of separate types of experiments here on this data. The first was trying to identify the top features. And this in particular, what we did was we took a number of different approaches for feature selection, because as with classification, there are many different options you could use, all of which seem intuitive on their own, and without data you don't know which one is best. So we wanted to find features that were actually reliable and good across many different feature selection techniques. That tells us that feature is really meaningful, that all these different approaches all say this feature is important for the data set. So we wanted to look at the features that ranked highly and say that these features are those that are relevant to our problem. And then once we found the most important features, we built classification models to say, can we predict based solely on the feature values, based solely on the independent information we have about these users from their Twitter accounts and their profiles, can we use these features to predict whether they're going to interact with or reply to a social bot? So let's go over. The tool we use primarily for this is Weka. It's from the University of Waikato in New Zealand. Open source tool, available for all major computing platforms, written in Java. Has GUI interface, though these experiments were performed using the command line interface, which is why I'm not showing you the interface, because it's just, typing in the command line and it's not particularly graphically interesting. But Weka is a very powerful tool for data mining. We've written a few extensions to add additional tools to it. But it lets you perform a lot of very interesting experiments trying to do feature selection and classification on different types of data sets. So this I'm going to go over very quickly. This is the interactive data set, the rank of the different features. Most important are the top three, which were clout score, friend count, and followers count, or I'm going to pull those out here. So these are the three features that are most relevant for whether or not a user interacted with the bot. In particular, the clout score was the most relevant. The people with higher clout scores were more likely to interact with the bot, and this was the strongest correlation of any other features. And then friends count and followers count were second and third place. So this shows us that users that have more friends are more likely to interact with the bot in some fashion, with friends or followers. Now what's interesting is the reply results are a little different. We still see clout score at the top here, but instead of the second place is no longer friends count or followers count. Those are down here and here. Instead, percent follow Friday comes higher. It's actually interesting. We see that there are different personality traits that lead to either interacting with social bots or replying specifically. That those who interact with social bots are more likely to have more connections, more friends and followers on Twitter, while those who actually interact are more likely to be involved in the Follow Friday tradition, i.e. trying to encourage users to learn about new individuals. So I found that extremely interesting, that even though these sound like two very similar classes, that we have people who interact with social bots or people who reply to them, there actually are meaningful differences here in that those who interact are more likely to have more friends, while those who reply are more likely to be actively engaged in the Follow Friday tradition. Now, following using the features from the top features, we built our classification models, and these are just a bunch of models we built. I'm just going to highlight the best model we have here was when we used top 40 features selected using a technique. Don't worry about the name of the technique. And we found that using this, we were able to build a model that had a true positive rate of 0.6130, etc. percent, and a true negative rate of 0.707 value. So to put that in perspective, this is the number of individuals in our true positive, false positive, true negative, and false negatives. Now, looking at this, you're going to say, so you're telling me that true positives are still outweighed by false positives. And yes, this is true. Our models, if our model tells you an individual is going to interact with the bot, it still is frankly more likely than not that they're not, because 87 of those individuals are true positives, but 188 are false positives. However, compare that with the gray outlines, which would be if you just guessed that everyone is going to interact with the bot. Here we see that we are having a significant improvement over the raw model of just trying to send the bot interact with everyone. So going out with what Chris was saying earlier is that if we want to minimize the chance that our bot is going to be detected, or that our bot is going to be, if someone is going to say, oh, that's a bot, flag for deletion, we want to reduce the number of false positives while trying to not harm the true positives as much as we can. So we're not expecting perfection here. We're not going to pinpoint with laser accuracy all the individuals who are going to interact with the bot and pick up none of those who will not interact. All we want to do is improve the odds, make it more likely that the individuals we target are the individuals we want to target. Now, we did similar work with the data set looking at only those who replied specifically. We found that it's a little harder to determine individuals that will reply and not just interact. We found that the performance was a little bit less. Our top model only gave a true positive rate of 58.58 and a true negative rate of 0.73. And it's just also found that different techniques worked well on this compared to the interacted data set. This goes back to what I was saying earlier. You have all these different algorithms. You have different classification models. You have different feature selection techniques. You can't just say one of these is going to always be your best bet. Because even on these two data sets that are very similar, only thing differs is whether the users were interacting with the bot or replying to the bot. Even these very similar data sets, different techniques performed well on these two data sets. So it shows the importance of considering different techniques and making sure you experiment and see what's going to actually work best on your real world data. And the overall results, similar type of procedure here. We see that our true positive is 89 individuals. Our false positive was 202 individuals, which again, we're still getting more false positives than true positives, but since we had many more individuals in the negative class, this is not entirely surprising, and all we're trying to do here is improve the odds, make it such that we will have a better chance of getting the individuals we want, even though we know we're not going to be perfect here. We know we're not building a 100% accurate model, but we're going to build a model that will make our bots survive longer and will let us find more of the users we care about. So overall, just the discussion is that the data sets had different properties, and it's just is interesting. It shows that you need to look your experiments on different models, but we're able to build models that could help us find the individuals we want more reliably than just trying to guess everyone and hope that we're getting people we want to find. So with that, what's the performance saying that one of the reasons we feel that we had worse performance on the replied data set was that there were fewer individuals who replied to the bot compared to those who interacted with it. So that led us to say that it's a little harder to understand those individuals because there are fewer of them, and you're more likely to get false positives because there are just so many negative individuals that you're going to find more of them overall. So that, I'm going to hand it back to Chris to wrap up the talk and give some conclusions.
Okay, so we'll just spend the next 5 minutes wrap up the talk here. So we found that extroverts were essentially at greater risk than introverts from interacting with a social bot, possibly phishing as well. There were some differences between the two data sets as well, but there's surprisingly little overlap. And that could be because people had like maybe automated follow back setup or just followed people back willy-nilly, but in terms of interacting, a lot less. We concluded really that models could help bot masters or those wanting to do that to find susceptible individuals, or at least reduce the chance of finding people who aren't going to respond. And in terms of why we think that's important, or worthy is that marketeers have definitely got skin in the game of trying to get more engagement, so it would behoove them to actually go try and find people who are more likely to respond. The propagandists may well want to focus on people who are more likely to push their message further out. Social engineers can at least reduce the chance of hitting people who are less likely to respond, maybe. And in terms of how would social network providers respond, well, there's a couple of ways that this could be, or this whole field could be useful. One is in the field of usable security. So in terms of the web browser context, this is kind of you hit on something that's got a certification problem and you're going to get a red bar rather than a green bar, and so on. So that concept there may be some version of that concept that could apply into social networks as well. I don't know, but it's a possibility, as long as it doesn't end up like this, if anybody remembers old Windows helpful icons. So the other area, and I think the area where I think there's like most potential straight away really, is in actually thinking about your training classes and like looking or understanding that a certain portion of your users are going to be very different to another portion. So for example, sales, which you might be maybe more extroverted than say the accounts department, maybe you give them sort of face-to-face training on sort of phishing awareness, but also they may be more susceptible in the first place. I'm aware that I'm interchanging phishing with social bots, but at some point the two kind of converge a little. And in terms of future research, one of the things, we had 2 questions that were associated with extroversion, where you could look a lot deeper into the big 5 factors. So you could look a lot deeper into extroversion, look at the facets of that, especially the facets related with impulsivity. And for impulsivity, maybe you could actually look at using the cognitive reflective test, which essentially, you can try this out now for yourselves, is a bat and a ball cost $1.10 in total, and a bat costs $1 more than the ball. How much does the ball cost? People who are more impulsive are going to answer that wrong more often. So there's some interesting studies on that, and that might be something which future researchers could do in looking at response rates to phishing and to social bots. And finally, our bot was really crude. We literally took the web ecology bot, modified it very slightly, kept in the same spirit of its banality, if you like, and really didn't do anything special. But you could go for a much more target-centric approach, where you're focusing on certain users and you're having your bot talk in a very in a meaningful way to that particular audience, rather than just being very generic. The final thing I wanted to mention is that it's not all bad, really. There's a chap called Lutz Finger, I don't know if folks are aware of him. He does a lot of sort of work on sort of data science, social media and what have you. And he was talking at a conference, the Strata conference earlier this year, and he said the dating site OkCupid had a problem with fake accounts. So what they did is they created this sort of identical environment to OkCupid, but essentially it was only had bot profiles. So when bots came into the real OkCupid site, they transferred them into this identical looking part of OkCupid, which was essentially bots talking and trying to date other bots. So that that's kind of allegedly, I've not found any evidence that OkCupid actually do that, but it's kind of amusing that that's how they're responding. So in wrapping up then, the paper I mentioned earlier, Ruloff and Kenneth Gears, really this still seems pretty true today, that illustrations from the Turing test and Blade Runner suggest that sufficient interactivity with a computer should reveal that it's not human. In some cases, people identified that we were a bot pretty quickly. So with that, we conclude the presentation. If anybody's got any questions, happy to try and answer them now. Yep.
Was there any attempt to interpret responses from the replies?
So was there any attempt?
So the bot reads someone's replies back. Did you make any attempt to try to parse out the language and respond accordingly, or is the bot's response to the reply just random?
Okay, so the question was really, did we try and parse the replies from the users and base the responses that the bot made based on those replies? And the answer to that is no, really. Essentially, the closest we got to that is we had an ELIZA engine that would actually parse and see if you said things like I think or hello or something like that, and would then have a number of canned responses that it could send. But in terms of anything smart, it was really pretty dumb. I don't know if that answers the question, but in terms of future research, I think there's a lot of mileage if you're looking at social bots into actually developing that, which looks at previous tweets, previous interactions of a user, and then basing your responses on that. I don't know, does that answer your question?
Yeah, it's just that I feel like you can't really base those conclusions that extroverted people are more likely to answer bots than introverted or vice versa, whatever, unless there's a second response or a third response or you're interpreting those things. I think you're just taking like a linear, basically a first order approximation of your responses. But so when someone responds with, the Turing test failed, is that included in the statistic where someone did reply to the bot?
That was included as a response, yeah, because the initial response was...
The person didn't believe that it was a real person.
After the second response, I think. The first response, they actually answered appropriately. And then in the second response, when the bot then responded in a dumb way, then they didn't respond further. So, and essentially to address the other point is research on social bots. The only other paper that's looked at research on social bots on Twitter was by Wagner et al. In 2012, which took the findings of the social bots competition and used that to identify. So we'd, I guess, like to state that it's a really small piece of research that we're doing here, which is scraping the surface, and hopefully the intent is if people are looking at personality and user behavior, maybe the findings we've got in terms of extroversion would get people maybe thinking about, okay, well, maybe it's broader than extroversion, or I need to look deeper into extroversion and those traits and design the next experiment accordingly, maybe look at impulsivity. So we're aware of if you like, the great limitations of what we're doing. But those are good points, actually, about the reply. And we did think about that, quite a lot. But then we were like, actually, they did respond once, and it was only when we responded to their response that, still, good point. Gentleman at the back.
How sure are you that all the users that you're communicating with
Because so can never be 100% sure, right? But the users that we took were users that had already signed up to a personality test, where they'd have to do a couple of things. They'd have to go through a consent form and then add the application and then fill out, it was like 10 questions for the big 5 personality traits and then 29 for the dark triad. So they'd have had to go through that. Now, yeah, you could automate it, but I'm not sure who would actually want to do that. So, I mean, I think the possibility of that is pretty low. Yeah. Yeah, there's a good reason for that. When we handed over the data to Randall, Randall's task really and their group were to look at how do you predict, you wouldn't find the personality data on Twitter. It's not a Twitter attribute. So we looked at what Twitter attributes and Twitter activity would enable us to maybe gain an advantage in terms of the social bot, whereas extroversion was just something we were interested in sort of correlation, if you like. So we didn't say, oh, do we know that a user is extroverted and how would that work?
Well, one thing I'd like to add is that, as Chris was saying, basically for the machine learning aspect, our concept was that in practice, a model you're not going to have personality profiles of these people. We have them because of the previous psychopathy research, but in reality, if you're a marketer, you're someone out there trying to find individuals to target for this, you don't have that information. The best you're going to have is clout score, and I feel clout score might have some correlation with extroversion. I think, did we find that?
I can't recall actually off the top of my head.
I would not be surprised to learn that there's a correlation there. So that sort of acts as a proxy a little bit. Obviously, it's not the same, but that's giving us the same idea. And yes, we considered looking at the way the personality traits directly could help build our models, but the concern there was that they would totally overwhelm the rest of the features, and then it wouldn't help us understand the actual Twitter features that are really contributing to whether an individual replies or interacts with the bot. Hope that answers your question.
Do you have an IQ score for Twitter?
No, we didn't have any other, information. So IQ would have been an interesting one. I mean, I think the whole area of social bot research and susceptibility, not just to bots, but to phishing emails, I think is a fascinating area for people who are able to move beyond the ethics issues, with that. But IQ, impulsivity, personality, all of those, I think, have got some underlying value, if you like, or utility to how people respond. But it could also be that people respond differently on different days depending on how they're feeling. So, it's really nascent research, and our objective was just to have a bit of a look. I guess that answers the question. Any other questions? All right, well, I really appreciate you guys sticking around and coming to see us. And on another note, I would actually really appreciate feedback. I'm my own worst critic, but very happy to receive any feedback. So if you wave your badges at whatever it is you need to wave them at, that'd be much appreciated. Thanks very much.